My voice is audible to everyone. Is it right? So I will now try to share my screen also. So please try to check once whether the screen is visible to you or not. Okay. So my continue my session now. My continue my session. Please respond through anyone chat box. My continue my session. Class. Okay, thank you. Okay, now I try to share my session. Okay, in the last class, we were discussing about what is a transaction and what is a transaction management and what is a transaction management properties and what are the states of transition and what is a schedule and what are the types of schedules also. I'm right. So schedule, what is a schedule actually? In the case of schedule, selecting any one of the transactions and decide which transaction is executed on that particular time. So that can be decided by using the schedule. Okay. So here in the case of schedules, we are consider the three types of schedules here. So one is the serial schedule, another one is the non-serial schedule, and another one is the serializable schedule. We're already discussing about this. So in the case of serial schedule, so one after completion of one transaction, executing the another transaction. So that type of the schedule will be referred to as a serial schedule. In the case of non-serial schedule, so before the completion of another transaction execution starts the execution of another transaction. So that means here performing the context switching. So this is same like as a operating system concept. So I'm already explaining in the last class. So in the case of process scheduling, we already know about this. We are having two types of schedulings there. So those are nothing but one is the preemptive scheduling and another one is the non-preemptive scheduling. In the case of what is the meaning of preemption? So giving the chance. Non-preemption means not giving the chance. We already know about this. Here, in the case of preemptive scheduling, so before completion of that one process execution starts the execution of another process. So that means it will be giving the chance. So that's why the type of the scheduling will be referred as a preemptive scheduling. And the example for the preemptive scheduling is in the last class also some of the person is giving the reply SRTF, shortest remaining time first, and another one is the round robin. In these two types of scheduling, in the case of operating system, so before even though one process is not completed completely, but starts the execution of another process execution. So that type of scheduling. In the case of non-preemptive scheduling, so if one process starts its execution, so that process is not allowed another process until the completion of its execution. In the same way, here also in the case of transaction management, serial schedule is the example for the non-preemptive scheduling, and non-serial schedule is example for the preemptive scheduling. Okay, I hope all of the members able to understood this. Okay, and another thing, serializability. So what is the meaning of serializability means? Okay, what is the meaning of serializability means? Nothing but here we are nothing but observing the outputs of both serial and non-serial schedules. If these schedules producing the same result on the same type of transaction, so that type of the result will be referred to as a serializable schedule. So otherwise it is a conflict serializability, okay, or non-serializability. So now we try to see what are the problems. So which type of problems are occurred during the during the execution of interleaved schedules. So what is the meaning of interleaved schedule? That is also same like as a non-serializable, non-serial schedule. Okay, so today we try to discuss about that. Why? Because so that is very important question, and this is the example for the serial schedule. I am already explaining this. After the completion of one transaction only starts the execution of another transaction. For example, in the exam point of view, may be asking about this type of question. So better you try to represent with the example and you try to explain the example also. If you observe here, so T1 and T2 is there. So these two are the transactions. am right? So initially read the account of Anu and write the account of Anu. Next read the account of Red and write the account of Red. Next starts the execution of another transaction. Again the same thing will be performed. So read Anu, write Anu, read Red, write Red. So that means how here if you observe the transaction executions, after the completion of one transaction only starts the execution of another transaction, am right? So this type of execution or schedule will be referred as a serial schedule. Okay. So the name is one after another. Okay. So next one is the non-serial schedule. I am just explaining about that. This is also same like as preemptive scheduling. Am right? So what is the meaning of preemptive scheduling? We will be giving the chance during the execution of one process, allowed for another process to perform the starts the execution. Am right? So if you are observing here, the same transaction is there. So read of Anu and we are performing some write operation. Next again, in the case of T2 also read operation performed and some performing some write operation. So write operation means nothing but we are performing some changes on the existing data. Okay. Next read read. Next write Anu. So read read. So in the same way write read. So here the same thing will be performed, but if you are observed here, so here we are allowing the chance for the another transaction before the completion of another transaction. Okay, so this type of schedules will be referred as a non-serial schedule. At the same time, so this can be also referred as a interleaved schedules also. Okay. So what is the main use of non-serial schedule means? So these are allowed for to perform the concurrent execution of transactions. So that means so these are used for to performing more to allow more than one transaction at a time to performing the transactions. If we are allowing number of transactions at a time to performing the operations on the same data item, so the type of the executions will be referred as a concurrent execution of transactions. Okay. In the exam point of view, also asking about what is a concurrent execution of transaction. Okay. So the Dbms interleaves the actions of different transactions to improve the performance in terms of increased throughput or improved response times for short transactions, but not all interleaving should be allowed. So that means if you are allow more number of transactions, that is possible through using the interleaved only. Okay. So what is the reason for to you or what are the advantages when we are using the interleaved transactions? That is nothing but motivation for concurrent execution. So if you observe the figure 8.18.1 that represents interleaved execution 1, two transactions ensuring that transaction isolation while permitting such concurrent execution is difficult but is necessary performance reasons. So that means here in the previous case here we are observing this. I'm right. In this diagram, we are already observing how the interleaved executions will be performing the execution. So advantages of concurrent execution of transactions. So the DBMS interleaves actions of the different transactions to improve the performance of system as discussed below. Improve throughput. So what is the meaning of throughput? So what is the meaning of throughput means nothing but how many number of outputs are generated within a time. So that can be used for to measure the throughput. For example, maybe we are consider some particular period of time. Okay, for example, we are consider one business. In that business, yeah, we are compare the profits of the last year from particular month to this year, this month. So that means how much of profits we are gained in the last year. So at the same time, how many number of profits we are gained in this year. So nothing but, so here we are consider the some sequence of outputs. So that means nothing but here we are measuring some particular outputs within a time. So that can be referred as a throughput. So that means if we are compare like that, so we are easily guess. So whether we are gets more profits in the last year or maybe in this year. I'm right or not? For example, maybe if you are consider the engineering college seats, how many number of seats are filled in the last year in that particular branch? In the same way, how many number of seats are filled in this year in the particular branch? So there is nothing also nothing but a throughput. Okay. So now try to see on the screen. Consider that the transactions are performed in a serial order, and active transaction is waiting for page to be read from the disk. Then instead of CPU waiting for a page, it can process another transaction. This is because input or output activity can be done in parallel with the CPU activity. So that means if you are observe the serial schedule and the non-serial schedule, in the case of serial schedule, each and every time CPU is performing the waiting, right or not? CPU is performing the waiting operation. So why? Because here need to write some data to the disk. Am I right? But in the case of interleaved execution, so maybe CPU is not having the free time. Am I right? So that is performing some actions. Okay, it can be processed another transaction. This is because input or output activity can be done in parallel with the CPU activity. The overlapping of input or output activities of, of CPU reduces the amount of time disks and processor idle and increases the system throughput. So that means the average number of transactions are completed within a time. Okay, so that is nothing but throughput, and in this type of we are increasing the throughput also. For example, in the case of serial transactions, so maybe if we are executing 4 transactions, so one after another, one after another, one after another, so CPU may be performing the waiting time. In the case of operating system also, you are calculating the how much of waiting time, how much of response time, how much of burst time. Am I right? So in the same way, here if you observe the throughput in the case of non-serial schedule, here CPU is not performing the waiting time. Why? Because in that waiting time, it will be executing the another transaction. So that means here increasing the throughput, and it will be able to execute more than one transaction within the same time. Okay. So next, reduce waiting time. Interleaved execution of short transactions with a long transaction usually allows here short transactions to complete quickly. So if you're observing the serial transactions, so maybe the total operations are there. So here context switching is not performed until the completion of all instructions. But in the case of interleaved execution, we are considered only short lines of instructions. Am I right or not? So why? Because remaining lines of the instructions are executed next. So that's why here only short lines of instructions are considered. So those are executed in the very fast mode. Am I right or not? So in the case, so here reducing the waiting time also. What is the meaning of waiting time actually? So when CPU is assigned to performing the execution, I'm right. So in the same way here also we are waiting when the transaction starts its execution. But in the case of interleaved execution, so easily transactions responded. Why? Because so T1 executed sometime, next T2 is executed sometime, next T3 is executed sometime. Again T1 starts its execution. So that means here waiting time is not there. So it will be reduced. Okay. So in this type of here, these are the advantages. So now a schedule S of an end transaction is serializable if it is equivalent to some serial schedule of the same end transactions. A serializable schedule contains the correctness of serial schedule while ascertaining better CPU utilization of parallel schedule. Serializability is widely accepted standard that ensures the consistency of a schedule. A schedule is consistent if and only if it is serializable. So a schedule is said to be serializable if the interleaved interaction transactions produce the result which is equivalent to the produced by the executing individual transactions separately. So that means what it means? So that means so serial schedule result and non-serial schedule result is same. So then only it will be referred as a it is a serializable schedule. Okay. So if you observe here, read of x, write of x, read of y, write of y. In the same way, T2 also performing the same thing. In the case, this is in the serial schedule. In the case of non-serial schedule, so read of x, write of x. Again, T2 performing the same thing. Next, read of y, write of y performed by the T1. Next, read of y, write of y performed by the T2. So that means here, if you are compare these two schedules, here and the above serial schedule and below non-serial schedule also produce the same result. So then we can say, so these two schedules in the serializability, the above two schedules produce the same result. These schedules are said to be serializable. Okay. The transaction may be interleaved in any order. The DBMS doesn't provide any guarantee about the order of which they are executed. That two different types of serializabilities are there: conflict serializability, view serializability. I think the name is implies. So for example, in some type of situations, maybe the same result is not occurred. So that type of the thing will be referred as a conflict serializability. View serializability means nothing but we try to maintain the serializability in that those type of transactions. Okay, so we'll try to discuss about this topic in the next classes. Okay, now we try to discuss about another important topic. So that is, this is also very important question. So and one more thing. So maybe I'm not able to take the classes from the tomorrow. So until up to Friday. Okay, maybe another sir will be conducting the classes. Okay, we'll send the link for you. I'm having some other work, so that's why I'm not able to take the classes from tomorrow onwards up to Friday. Okay, maybe Tuesday, Wednesday, Thursday, Friday. So again, I'm taking the class on the Saturday. Okay, please try to cooperate with this. And if you're having any type of the doubts, you can contact me personally. Okay. So today we will try to discuss about this topic. So anomalies due to interleaved exclusion. So we also know about this. What is the meaning of anomaly? So anomaly means nothing but an error. Okay, so when we are consider the interleaved executions, those are having so many advantages. So what are they? Increasing the throughput or reducing the wait time and able to execute more number of transactions. Am I right? So and it will be useful for to perform the concurrent execution of transactions. So all these are the advantages. At the same time, so when we are considered the interlude execution, maybe we are having some types of problems also. So which type of problems are occurred? So we just to try to see. Okay, the scheduling involved two transactions shown in the table R1 represents interleaved execution of two transactions. While one transaction is waiting for a page read from the disk, the CPU can process another transaction. This is because input-output activity can be done in parallel with the CPU activity in a computer. Overlapping output and CPU activity reduces the amount of time and increases system throughput, which is the average number of transactions completed with in a given time. So that means if we are observing here, so the CPU will be perform some other activity, and here, so maybe here we are performing some waiting operation. Okay, so why? Because here we need to execute more number of transactions within a time. So interleaved execution of a short transactions with a long transaction usually allows short transactions to complete quickly. In serial execution, a short transactions could get stuck behind a long transaction, leading to unpredictable delays in response time or average time taken a complete transaction. If you observe here, two transactions are there, T1 and T2, read of A and write of A, and read of B and write of B, and read of C and write of C. Okay, there are three main situations when the actions of two transactions, T1 and T2, conflict with each other. So in the interleaved execution on the same object. So the three anomalies associated with the interleaved executions are follows. So those are referred to as read-write conflict and write-read conflict. And another one is write-write conflict. In the exam point of view, these type of topics are very important. Okay, please try to observe this. Write-read conflict, read-write conflict, and write-write conflict. So that means here maybe the chance of occurring the overlapping between these transactions. So maybe, so if you observe here, write-read conflict. So that means if we are considered two transactions, T1 and T2. So that means if T1 performs the write operation at the same time T2 performing the read operation. So that is the actually error transaction. Am I right or not? So at any time of the situation, we need to maintain the consistency. Am I right? So in the same way, read-write conflict. So T1 performs the read operation and T2 performs the write operation. So at that time of the situation also, when we are getting some different types of results in the same way, right. So that means T1 performing some write operation and T2 performing the some other write operation on the same data item. So that is nothing but a right conflict. Okay, so now we try to see, and you please try to remember with the names also. Reading uncommitted data, so that can be referred as a right read conflict. Okay, reading uncommitted data. Here we are maybe occurring the problem with the transaction T2 only. So here we are consider two transactions T1 and T2. Here occurring the problem at the place of T2 only. Okay, so if you are observe here that the title reading uncommitted data. So that means T1 performing write operation and T2 performing the read operation. So that means during the during the some changes on the particular data item, at the same time T2 will be reading the same data item. Okay, so that is nothing but reading uncommitted data. Simple. So reading uncommitted data. So if we are reading uncommitted data, then what happened? So that means we are retrieving some other error value. I'm right or not? So if you observe here, so just to try to explain through example. If you observe here, the first source of anomalies is the transaction T2 could read the database object A has been just modified by another transaction T1. So that means T2 performing the read operation, but that is just modified by just still modified by T1. So but in that that modification is already also not complete up to now. So that type of read will be referred as a dirty read or reading uncompleted data. I think all of the members able to understood this. So the name is implies here reading uncompleted data. So that means so whenever write operation is performed on that particular data item, at the same time DT will be performing the read operation. So then so that type of the error will be referred as a reading uncompleted data. So when we are read uncompleted data, then automatically we will be retrieve some error values, right? So if you observe here T1 and T2, read of A and A equal to A minus 100 and write of A. Okay, so that means what happened here? So if you observe, so reading the A data item and performing some changes on the A, and that is those type of changes are written to the disk. But here we are not using the commit if you observe here. So but at the same time, T2 will be performing the A value. Okay, and A will be maybe performed by some other modification and try to commit that transaction. So if you observe, so another transaction will be maybe executed here. So at this time of situation, so definitely we will be able to get the error data. Am I right or not? So why? Because here one of the transaction performing the write operation on that particular data item, at the same time another transaction performing the read operation. So the type of the error will be referred as a so nothing but reading uncompleted data. Okay, so this is also one of the problem. Okay, and next, so we try to discuss with the another topic. So that is nothing but read write conflict. The previous one write read conflict. Okay, so here we are read write conflict. So that means T1 performing the read operation and T2 performing the write operation. So the second source of anomalies is that transaction T2 could change the value of the object A that has been just read by the transaction T1. So that means initially transaction T1 performing the read operation on that particular data item. At the same time, T2 will be performing the some write operation on the same data item. That the type of the problem will be referred as a write read conflict. Okay, so if you observe the example, so suppose two transactions consider T1 and T2 read the same value of A and A value is initially 5. Okay, T1 has incremented A value is 6, but before commitment of A value is 6, T2 decremented the value 5 to 4. The instead of answer A is 5, that is from 65, we got answer is 4. So which is incorrect. So that means if you observe A value initially equals to 5. Okay, now T1 wants to read the data item and incrementing that value. Okay, incrementing that value by 1. So then what is the value of A if it is completed successfully? 6. Okay, so during the execution of this transaction, another transaction will be performing the write operation on the same data item. So that is, so one value decremented by 1. So if it is successful, so then what is the value of that A4 actually? Okay, but here if we are retrieving the value of the A during the execution of these transactions, so then the A value is incorrect. So why? Because none of the transactions performing the commit. So that is the type of the problem will be referred as a unrepeatable read. So that means more than one time the read the same data item. So the what is the previous one? It is a dirty read. Am I right? It is a dirty read also. Dirty read or reading uncompleted data. Please remember this, and maybe so these type of points are used in the maybe online bits exam. Okay, online quiz exam. Okay, in the exam point of view also this is very important. Okay, what are the anomalies due to the interleaved exclusion, or maybe directly asking about what is a dirty read, what is a reading uncompleted data, what is a blind writes. So like this, so directly asking the question. Okay, I hope all of the members able to understood this. Okay, okay, the first one is dirty read and the second one is unrepeatable read. Okay, and now we try to discuss about the third one, that is nothing but overwriting uncompleted data. Okay, so the type of the conflict will be referred as a write read conflict. If you observe clearly each and every conflict, so you can divide like this. For example, if it is a read write conflict, So T1 performs read and T2 performs write. If it is a write read conflict, T1 performs write and T2 performs read. Okay. So now if you observe the write write conflict, so that means what it means, T1 performs the write operation and then say at the same time T2 also performing the write operation on the same data item. So the third source of anomalies is that transaction T2 could override the value of an object A, so which has already been modified by transaction T1 and while T1 is still in progress. So that means here, so transaction T2 performing the write operation on the A. So at the same time, so T1 is already modifying that value of that A. So the type of the problem will be referred as a write conflict. Okay. So for example, just to consider one example. Suppose that A and B are two employees and their salaries must be kept equal. So transaction T1 sets their salaries to $1,000 and transaction T2 sets the salaries to $2,000. Okay, so that means here, if you observe here, so main thing is here we are consider two employees. A and B are the two employees and their salaries must be equal. Okay, so transaction T1 performs salaries to $1,000 and transaction T2 sets their salaries to the $2,000. Okay, for example, maybe if you are observing the following interleaved executions, T1 and T2 occurs. For example, T1 sets A salary to the $1,000. At the same time, T2 sets the B salary to the $2,000. Okay, again, T1 sets the B salary to the $1,000. At the same time, T2 sets A salary to the $2,000. As a result, A salary set to the $2,000 and B salary set to the 1,000. The result is not identical. We are observe here. So here the problem is initially T1 wants to performing some changes on the A value. Okay. Next, T2 wants to perform some changes on the B. So again, T1 wants to performing some changes on the B. At the same time, T2 wants to set the changes on the uh, yeah, so that means here what it means here occurring the problem. So that means one of the transaction performing the write operation on the same data item. Again, the same operation will be performed by to the another transaction. So the type of the problem will be referred as a write conflict. So that means up to now we are discussing about three types of conflicts. I will just try to repeat. So please remember the examples also. In the exam point of view, this is very important question. So which type of anomalies are occurred due to the interleaved execution? Okay, so if you observe here, so three types of conflicts are there. So write-read conflict, read-write conflict, and write-write conflict. Okay, in the case of write-read conflict, so here T2 performing the read operation. So during the execution of T1 write operation. Okay, here in the case of read-write conflict, so T2 performing the write operation. So but the transaction just read by the T1. So if you observe the write-write conflict, in the case of T2 performing the write operation, the same thing will be modified by the transaction T1 also. So here each and every conflict here now occurring the problem occurring the problem so occurring the problem we are not using the commit here, so that is the main problem. Okay, so that is the main problem. So if you are commit then there is no problem. So that's why we try to avoid these type of situations. Okay, and please remember all these names also. Reading uncommitted data means nothing but it is the first conflict. So that is okay. So please try to remember the names. Write read conflict. So that means here occurring the reading uncommitted data. Okay. In the case of read rate, so that is nothing but unrepeatable reads. So if it is a write rate, so it is a nothing but overwriting uncompleted data. At the same time, blind writes also. Okay. So these type of problems are occurred when we are allowing the interleaved executions. Okay. So now we try to discuss about the schedules involving aborted transactions. So all actions of aborted transactions are to be undone. So and we can therefore imagine that they are never carried out begin with. So for example, transaction T1 deducts some amount 100 rupees from A and then immediately before committing a new value to the transaction T2 reads the current value of account A and B, adds 6% interest to each, then commits, but incidentally T1 is aborted. So we get incorrect result of transaction T2 because T1 was aborted in the middle of the process of T2 has taken incorrect value of A and by T1 and added 6%. We say that such schedule is unrecoverable schedule. So the corresponding schedule is shown in the table. For example, just please observe this. So in the case of T1, read the value of that item A and by deducting some amount, 100 rupees from the A, and return to the disk, but not using the commit, just only performing the update command only. Okay. So next, T2 performing the read operation on the A and 6% of A is added to the A, and that is performing the write operation on the A, and read operation of B, and 6% of B, amount of B is added to the B, and performing the write operation and commit. Okay. So at this time of situation occurring the problem. So that means here, for example, if the T1 is aborted here, if you observe T1 is aborted, so that means the transaction will be produced some error result at the same time, so that thing will be not will be recovered here. So at that amount situation, the T1 will be treated as a new transaction for to the Dbms. So that is automatically invoked by the Dbms. Okay. So to try to reduce these type of occurrences by using a lock. Okay. So that can be referred as a lock based concurrency control. So that means when we are allow more than one transaction at a time to performing the same operations on the data items more than one transaction, so then we are using the locks. So then that is possible through to performing the executions, concurrent executions. Okay. So a lock is a variable actually. A lock is a mechanism to control concurrent access to a data item. For example, here if we are giving some lock on the particular data item, then remaining transactions not able to take the lock on the particular data item. So that means here remaining transactions performing the waiting operation until releasing the lock. Then so here not occurring the error data. Okay. Lock is nothing but a mechanism that tells the Dbms whether the particular data item is being used by another transaction to performing either read or maybe write operation. Okay. There are two types of operations here, read and write. So whose basic natures are different, and locks read for read and write operation may be behave differently. The simple rule of locking can be derived from here. If a transaction is reading the content of shareable data item, so then any number of other processes can be allowed to read and content of the same data item. But if any transaction is writing into the shareable data item, so then no other transaction will be allowed to read and write item same data. So that means, for example, if you are if you are allowing more number of transactions at a time, for example, we are allowing 5 transactions: T1, T2, T3, T4, T5. Okay, so all these transactions wants to perform the operation on the same data item A. Okay, for example, if that operation is read operation, then we can allow 5 transactions. Why? Because here, in the case of read operation, just only retrieve the value of A, but not performing any type of the changes on the A. So, but if any one of the transactions wants to perform the write operation, then remaining transactions will be performing the waiting operation until the completion of that particular write operation on the data item A. Okay. So here, so that purpose is fulfilled by using the issuing the locks. Here we are considered the two types of locks here. So those are nothing but one is the shared lock and exclusive lock. Shared lock means nothing but used for performing the read operation, and that will be represented with the lock S. Okay. Exclusive lock. So that will be performed both read and write operations. But once exclusive lock is issued for some particular transaction, the remaining transactions not able to allow to perform the operations on the same data item until releasing the lock by the particular transaction. So at this time of situation, remaining transactions not able to performing any operations, then not occurring the problems. I'm right or not? So in the case of interleaved execution problems, write read conflict, either read write conflict, or maybe write write conflict. So one of the transaction may be locked on the particular data item. The remaining transactions not able to perform any other operation. There is no chance of occurring the problems there. Okay. So before issuing any type of read any type of data item, first of all we try to verify whether it is a shared lock or exclusive lock. If it is a shared lock, we will be able to perform the write operation or maybe the read operation. If it is a already acquires exclusive lock, then need to perform wait operation. Okay, just to try to see in the screen. Okay, a transaction may acquire shared lock on data item P in order to read its content. So that means this is used for to performing the read operation on the particular data item. So the lock is shared in the sense that any other transaction can acquire shared lock on the same data item P for the reading purpose. So that means here we can allow more than one transactions to performing the read operation. The lock is shared mode. So we can issue any number of shared locks on the same type of data item. For example, so shared data item is P. So T1 acquires the shared lock, T2 acquires the shared lock, T3 acquires the shared lock, like this. So in any number of transactions acquires the lock on the read data item. Why? Because here there is no change. So when that operation is completed, in the same way, exclusive lock represented with the X, a transaction may acquire exclusive lock on a data item P in order to both read and write operations to it. So the lock is exclusive in the sense that no other transaction can acquire lock any kind of lock, either shared or exclusive, the same data item P. The relationship between the shared and exclusive lock can be represented by the following table is known as a lock matrix. So that means, for example, if it is a shared lock on that particular data item, so another transaction will be able also to perform the shared lock. So that is true. Okay. In the same way, by using shared lock, we can't perform the exclusive operations. Okay. For example, if we want to, if we are issuing the exclusive lock, so then remaining transactions not able to performing the share. At the same time, the remaining transactions not able to perform the write operation. So today we are just discussing about due to the interleaved execution anomalies. So write-read conflict, read-write conflict, write-write conflict, and another thing is, so what is about how the transactions are aborted and how the transactions are nothing but executed. Okay, and another thing, so what is a concurrent execution transaction, and what are the locks, and what is a lock management system in a transaction management. Okay, I hope all of the members able to understood this. Again, I'm try to say this, so I'm not able to take that. Please just wait 1 minute. If you're having any type of the problems, so ask me now. Otherwise, we will end the session today. So we're already in the last unit, and we are already completing the half of the syllabus of last unit also. So another half of the syllabus will be related to the storage. Okay. So we will try to discuss those type of topics in the next class. Okay. End my session now. Okay. Thank you, Ananda. Take care, all of you. Have a nice day. Thank you, Ananda. Have a nice day. Take care.